it's Gabrielle, and this video is a sample from Studyclix Boost, our new rapid revision tool. Go to studyclix.ie/boost to find out more.
So, in this question, we're going to be asked to sketch the function. So the first function we're asked to sketch is a quadratic function. Now I know it's a quadratic function because it has two factors. My two factors here are x plus 1 and x minus 4. Now that'll enable me to get the roots of the function, and when I say the roots of the function, I simply mean where it cuts that x-axis. So where it's going to be like say 1, 0, 2, 0, 10, 0, whatever it may be. Now the thing that you must remember is when it cuts the x-axis, y is equal to 0, and when it cuts the y-axis, x is equal to 0. So anyway, let's get bogged into this question. Sketch this quadratic function. This f of x is equal to x plus 1 and x minus 4. Now I'll encourage you always to do, when we see f of x, g of x, p of x, simply replace it with y. And by doing that, we'll not get confused with our x and our y axis. Now, we're going to use the fact that it cuts the x-axis when y is equal to 0. So we're going to find where it intersects that x-axis. So all I'm going to do now is replace my y with 0 and let these factors, the two factors there are x plus 1 and x minus 4, equal to 0. And then x values written as points become minus 1, 0 and 4, 0. Because remember, a point is made up of an x and a y, and our y is 0 when it cuts the x-axis. Now the other thing that we've got to work out to get a relatively accurate sketch of this quadratic function is find where it cuts the y-axis. And it cuts the y-axis when x is equal to 0. So we have it written as y is equal to x plus 1 and x minus 4. So all we're going to do is, everywhere we see an x, sub in 0. Brackets obviously mean a multiply. Y is equal to minus 4. No need for the brackets around that. Just getting carried away. And to write that as a point, it's 0 minus 4. Alternatively, someone might have multiplied out them initial brackets, getting x squared minus 4x plus 1x minus 4. And then we see we're left with a minus 4 at the end when we sub in 0 for our x. Whatever way you wish there. And now we'll get a sketch of that function using the roots and seeing where it cuts the y-axis. Someone on the ball there might find the turning point of that function by either completing the square or by carrying out differentiation dy dx in the function and letting it equal to 0, and you'll get the turning point of the function. So simply plot our roots, our minus 1, 0 and our 4, 0. We know it's going to be a u-shaped function, but the other bit of information that I would like here is where does it cut that y-axis, and we work that out to be 0 minus 4. And then join them up in a nice smooth curve, and you get something that looks like that. There's our fx function. A general u-shape. A general u-shape, as I say, with an asterisk beside it. But a u-shaped function holding water that'll never cut back from itself. We've got our two roots here, and that's the key point. As I say, for the crack, work out your turning points. If you know how to, by completing the square or by carrying out differentiation, and you'll get some bit of information down there. We'll do another question. So in this one, we've got to sketch a cubic function. Now, there's two forms of a cubic function like you have in your quadratic. You can have a plus cubic or a minus cubic, and I may as well show you that. I always think of minus x cubed first of all. Minus x cubed is an S shape. And the reason I remember that, I used to teach someone called Sarah. She was always given out. So I always say, Sarah, you're very negative. So a minus cubic function is an S shape. So the opposite to that, if I had a plus x cubed, just the opposite. Instead of going downhill first of all, or instead of holding water, you're spilling water, then into holding water. Just the opposite shape, symmetrical to that. Flipped over itself, I should be saying there. Right, so we've got to sketch this function. A bit of a problem here is, unlike the first question there, it's not split into the factors, so it's not as easy for us. So what we must do is determine one of the factors first of all. And what we do is horse in values, generally 1, 2, 3, 4, minus 1, minus 2, minus 3, minus 4. That'll find one of the roots, and then we turn that into a factor and do long division. So a cubic's going to have 3 roots and 3 factors. So we must trial and error here in order to get that first root or the first factor. So a good place to always start is sub in p of 1 in for my x, and if it is a root, as we've seen in the previous one, it's going to be 0 as our answer, because it's cutting that x-axis at 1, 0. And lo and behold, we get the answer to be 0. So this is a root. So x is equal to 1 is our root. Now we must turn that into a factor. To turn that into a factor, just simply bring across the 1, working in reverse. So our factor there is x minus 1 is equal to 0. So the clear distinction between a root and a factor. Now, we said there's going to be 3 roots and 3 factors. A factor is a number that divides into another number. So we're going to do long division of x minus 1 into that original function. And all we've got to say to ourselves, always the first term into the first term. What do we multiply x by to get x cubed? It's x squared. And then times that by the factor. And there'll always be a row of cancelling going from left to right. So x squared times x gives me x cubed. Minus 1 times x squared gives me minus x squared. And then we draw the line and change the signs. So draw the line, change the signs. We're getting our cancelling. Going on x cubed minus x cubed. Adios. 4x squared plus x squared gives me 5x squared. And then bring down your minus 5x. And just repeat the process. What do you multiply x by to get 5x squared? We have 5x. And times it by the factor. So 5x times x gives me 5x squared. 5x times minus 1 gives me minus 5x. And as we said, draw the line, change the signs. Draw the line, change the signs. They disappear. We know we're good. So one of our factors was x minus 1. The remaining factor was x squared plus 5x. That's still hidden away as a double factor. So now we must factorise that. So a bit more crack, a bit more entertainment for us. Split up that x squared plus 5x. Your first type of factorising you would have learned back in the old day is taking out your common factor. So you're taking out your x and your x plus 5. Therefore, our function p of x, instead of being written as the original function x cubed plus 4x squared minus 5x, is now written as, so it doesn't matter what order you write those in, but if I multiply those 3 factors together, I end up with the original function. Now, like we did in the previous one, everywhere we see h of x, f of x, p of x, replace it with your y, and use the fact that when it cuts the x-axis, y is equal to 0. So we're turning those factors into roots, and some of you might be able to do that quickly. Batter on, do it, speed it up for yourselves, but we'll just take it stepwise. And all you've got to do, let each of the factors equal to 0. So x is equal to 0 is one of your factors. X plus 5 is equal to 0. And x minus 1 is equal to 0. Solve for x. And then to write them as points, x and y, we've got our x's, just fill in 0 for your y. And then the only other thing that we would like from this is where it cuts the y-axis. And what cuts the y-axis when x is equal to 0. And if you filled in, looking back up here, if you filled in x to be 0, you'll see you'll end up with 0. So it cuts the y-axis at 0, 0. Alternatively, fill it into the line below your factors. And anything when it's just x, it's like multiplying by 0. So it's all going to disappear. So we'll have a wee sketch at this now. And then just fill in your roots. So 0, 0, minus 5, 0, and 1, 0. There's my 3 roots. Now we've seen there in a plus x cubed, we have this shape here. So remember, Sarah being negative, it's not the S shape. Whatever you call opposite to an S shape, it's not your S shape, so we're going up first and then down. And join it in a nice smooth curve and label it. There's our function p of x. Now, again, if you've done calculus, by all means find the turning points, your stationary points, by definite, dy dx, and let it equal to 0. and you'll have something else. You'll have another feather in the cap. But for the purpose of this, if we can identify the roots, identify where it cuts the y-axis, we're flying. But as I say, if you know your differentiation, if you know your calculus, by all means, definitely let it equal to 0, and you'll get the maximum turning point and the minimum turning point, and it'll be that wee bit more accurate.